Hello students, how are you? I hope you all are fine. Okay. See, this is going to be our second part of the video of the lesson motion of your class 9 textbook. Okay, this is the physics part. Okay, so today we will start from the point or the part where we actually ended. Okay, so for today's class, your first topic is going to be uniform motion and non-uniform motion. Okay, before starting that topic or before move towards the definition of the uniform motion and non-uniform motion, we should always start from the simple part. And simple part is, first we should actually look what actually mean by uniform and non-uniform. See, this is the time where all schools are off. Okay, but there's a time now when you actually used to go to school, right? In school, what happens? There's a uniform for us, right? That uniform means what? Okay, everyone is equal. Okay, there is no rich, no poor, right? That uniform actually gives us. In this case, or in physics, or in this lesson motion, what uniform is going to mean, we are going to understand with an example. First, I will consider one car. Okay, this is one distance. Sorry, this is not one distance. This is one position, A position. Okay, this is the B position, and this is the C position, and this is the D position. I will consider that this car changes its distance or changes its position from this A position to this B position. Okay. Okay. Again, from B position it will move to the point C position. Right. Again, from C position it will move to the point or position D position. Okay. Again, if I say from A to B the distance is 10 meter. Again, from B to C the distance is 10 meter. Again, from C to D, the distance is 10 meter. What you have actually seen that from A to B, from B to C and C to D, all the distances are same. Okay, the condition is, maybe you are thinking that, okay, that if the distance is same, then maybe it is the uniform motion. No. But there's one more condition, that when that car was actually changes its position from one position to the other, it should change its position from one position to the other in equal interval of time. If it is changing its position from 2 minutes, and from B to C, it have to change its position in similar amount of time. Okay, similar amount of time. That means we can say as a definition of the uniform motion that whenever an object changes its distance equally, okay, in equal interval of time, then that motion, or that means what? That motion means what? Motion means what? Changing of its position. Okay. Whenever we change our position, we are going to get some distance, right? So we can say that whenever an object changes its position from one position to the other, or changes its distance equally in equal interval of time, that motion is going to be known as what? Uniform motion. Okay. Again, now come to the non-uniform motion. See, non-uniform means what? Formal dresses like that, na? Whenever we wear formal dresses, okay, we went to a party with formal dresses. Then what happens in party? No person is wearing the same amount, okay, similar amount of clothes, right? Somebody is wearing plain shirt, somebody is wearing check shirt, right? And every people have wearing actually different colors of shirts and actually saris, lots of whatever you want to think. Okay, so in this case, what is happening? First, I have considered for information that the distance are same. But if I now change the distance from 10 meter, 20 meter and 30 meter, that means what? The distance is actually different, right? If the time should be same. But in this case, we can say that whenever an object changes its distance unequally, but in equal interval of time, that that motion is going to be known as what? Non-uniform motion, right? Similar thing, right? But two major differences that in case of uniform motion, the distances and time are going to be same. But in case of non-uniform motion, but time is maybe going to be same, or time is same, or you can say the interval of time is same, but that distance from one position to the other is going to be different. Understood, na? That is the uniform motion and non-uniform motion. If there is a question in exam that write the difference between uniform motion and non-uniform motion, write the definitions. It will be of 1 mark question. Okay, so don't worry about that. Okay, our next topic is measuring the rate of motion. Till now we have actually understood what is actually motion, right? Now we have to look what will happen if the motion changes depending on, okay, on based on a certain physical quantity, right? And we will again move towards that physical quantity. What that physical quantity will be here, we'll actually move towards that. First, the thing is that word rate, right? To understand the word rate, first I will consider one example, okay? We all have till now we have all have gone to a market, right? Whenever you went to a market or you go to a market, what is going to happen? You just ask the seller that what is the rate, okay? That seller is going to reply that per kg 20 rupees, per kg 200 rupees, per kg 50 rupees, whatever you can actually think. But in case of physics, okay, that rate is always going to be time. That means if anything, okay, changes, if we say that the rate of motion, that means what? That motion is going to change per unit time, right? And that unit time is going to be 1 second or 1 hour. Okay, in class 9 we will mainly deal with 1 second or 1 hour, nothing other than that. Okay, now we will again move towards the topic measuring the rate of motion. Now I think you have understood the meaning of rate, right? We can say that whenever the word rate means if something in physics actually changing with respect to or per unit time, that is going to be known as the rate. Okay, and in physics we always deals with time to measure the rate. Okay, now we will again move towards the topic, the measuring the rate of motion. See, again consider one more example, that if this is a running track, okay, consider this is a running track, okay, this position is going to be the starting position, okay, and this is going to be the ending position. Okay, there is, consider 4 runners are there. Okay, there are 4 runners. Okay, whenever the referee is going to give them a signal, they will start running. Okay, the condition is I have considered the 4 runners of different sizes, okay, different strength, different stamina, right? When they start their running competition, what is going to happen? Whenever they reach the position B or the ending position, just tell me one thing, are they going to reach that position at a similar amount of time or the same time? Obviously not, right? That is the thing, okay? Many objects actually move towards a point at different amount of time. That means what? That motion is now depending on time or changing with respect to time. That means what? If we are describing a motion that with time, that it is that motion is same, that motion is different, right? That motion is actually increasing, that motion is decreasing with respect to time. That means what? We're actually discussing about the rate of motion, okay? And that rate of motion is mainly known as speed. Okay, speed. Okay, again we all know that speed is a scalar quantity. Why it is a scalar quantity? Because speed only deals with what? Magnitude, right? Speed only deals with magnitude. Again, the actual definition of speed is going to be the rate of change of distance per unit time is going to be speed, right? First I will erase this part. That speed is going to be what? The rate of change of distance per unit time is known as what? Speed. Understood? Mathematically we can actually express as speed is equal to distance per unit time. That means if the distance changes per unit time, that means if I consider that if a car is traveling 30 kilometer in 1 hour. This thing is going to be known as what? Speed. That means we can always write now that 30 kilometer per hour. Okay. Whenever we move in a car, if somebody asks you what is the speed, okay, never say that it was moving in 30 kilometer, right? You have to mention properly that 30 kilometer per hour. That means in 1 hour it was moving in a speed of 30 kilometer. That means in 1 hour it will cover a distance of how much? 30 kilometer. Simple, right? Again, as I explained you about that car, right? Why we actually consider the car? Because it was completely actually imaginable to us. Na? We can, if I say a word that car, it's quite obvious for us that we all have seen cars. Okay, we all have actually witnessed car, right? Now the thing is, if I consider a track, if this is a track or this is a road, if this is a car that is actually moving in this road, what do you think? That car will move at a certain speed or the same speed throughout its journey? Just consider yourself in a car, yourself is sitting in a car and you are moving from one city to the other city. What do you think? Your speed is going to be same throughout the whole journey? No, na? That means what? At a certain moment you are going to have a speed of 40 km per hour, at a certain moment you are going to have a speed of 60 km per hour, and at a certain moment you are going to have a speed of 100 km per hour. In that case, if somebody asks you, okay, that what was your speed, then what will you say? You're going to have no specific speed, na? In that case, we are going to need one more term, and that term is known as what? Any idea? That term is known as average speed. Okay, average speed. Now, just to make you understand what actually average speed means, see, when you pass out from class 8 to 9, okay, what happened? Just forget the corona. Okay, just forget the corona. What happened? That your teachers calculated your whole marks depending on all of the exams, okay, you have appeared in class 8. Okay, not a single exam that you have actually appeared, right? Annual exam, not in only one exam. They have taken out the average mark, okay, from all of your exams that you have appeared in your class 8. Similarly, what is going to happen? As I told you one example, that if a car is moving at a first, in 1 hour it is moving at a speed of 40 km per hour, in the next hour it is moving at a 60 km per hour, and at the next 1 hour it is moving at 100 km per hour, okay? So in that case, how will we calculate? First, we will add all of the things. That means 40 plus 60 plus 100. And all of them are in kilometers, right? But total time, how much it take total time to reach from one position to the other? Consider that almost 20 hours it has taken, right? From moving from one city to the other, 20 hours. Just consider it. Maybe it is going to have some long journey, right? Then what is going to happen? We will calculate that 40 plus 60, 100, 100 plus 100, 200, 20, 10. That means kilometer per hour. Okay. The answer is going to be what? 10 kilometer per hour. This is the average speed for that car. Okay. So from this mathematics, what we have actually understood, or how we can actually say the average speed as total distance traveled, right, divided by total time taken. This is going to be the definition of average speed. Understood? Quite simple, no? But now I have one question. Okay, if I ask you why speed is a scalar quantity, okay, though I know that is a magnitude or is only deals with magnitude, but before speed you got one more term. That term is going to be what? Distance. And distance is what? Distance itself is a scalar quantity. If we actually deduce another quantity depending on a scalar quantity, this new quantity is obviously will be a what? Scalar quantity. So It is like that. Again, average speed is also going to be a scalar quantity. Understood? That's why we actually needed. If somebody asks you why we need average speed, simple question, na? Actually, most of the object moves at different speed. Okay, non-uniform speed you can actually consider non-uniform motion, non-uniform speed. So non-uniform means what? Continuously changing with time, right? So that's why we need the average speed to actually understand the whole speed, okay, throughout its journey, okay, at a perfect or a specific speed. If somebody asks me what was your speed when you have moved from city A to city B, okay, we can't tell. First hour we have moved at a speed of 20 km per hour, in the next hour we have moved at 40 km per hour, in the next hour we have moved 60 km per hour. We can't say like that. We have to tell them at a specific speed. To calculate that specific speed, we always need average speed. Okay, understand now? This is the main thing about speed. Again, okay, when we will actually cover speed, velocity and acceleration, after that coverage, I will actually discuss some problems too, some important problems that we are going to need in your exams, okay? So, be ready for that. First, I think you have understood the concept of speed, okay? Now, we will move towards the next topic, okay? That is one more interesting one, okay? Now, we are actually dealing with physics. Now I think that you are actually understanding what actually physics is, okay? In the first class, I actually told you that physics always helps us in learning the answer of why, okay? That why. We always deal with why, okay, with physics, okay? It will be more interesting. Just you have to give some attention, okay? Watch the video attentively, then you will understand everything, okay? I'm always there. Don't worry about anything, okay? Now we'll move towards the next topic. Our next topic is going to be speed with direction. For our knowledge, okay, from our knowledge, we can say that speed is magnitude. Speed is magnitude. Maybe some students are actually thinking, how speed is magnitude? Because see, speed is what? Scalar quantity, and scalar quantity deals with only what quantity? Magnitude. That's why you can simply say that speed is a magnitude. Again, the next thing is, it is that what? It is, this word is what? Direction. Okay. And from our concept or from our knowledge, we can say whenever there is presence of both magnitude and direction, these two quantity actually going to give us what? What physical quantity? That quantity is nothing but vector quantity, right? Vector quantity. That means we can say that when we give direction to speed, we are obviously getting a vector quantity. Or the quantity when we are giving direction to speed, that quantity will be a vector quantity. Now, what is that quantity? Okay, and what that quantity actually known as? Right? See, whenever we give direction to speed, speed was what? The rate of change of distance with time. Okay. Now, if we give direction to that change of motion, that speed is going to give us some comprehensive value. Okay. Getting some specific value. Okay. Consider one car. Okay. One car. That car is actually moving, consider that, just example, consider that it is moving at a speed of 60 km per hour. Okay, till now we do not know in which direction it is actually moving. Okay, but if I say that if that car is actually moving at a speed of 60 km per hour in the direction of east, then this whole thing is going to be what? Vector quantity. Okay, and that vector quantity is known as, I hope you know that, velocity, right? The velocity. Whenever we give, okay, the direction to speed, we are going to get velocity, but the definition of velocity is different. Okay, the definition of velocity is the rate of change of displacement with time or per unit time is known as velocity. Now the thing is, first I will erase this part. Okay, in case of speed, what we have got? The rate of change of distance per unit time, but the velocity will be what? Rate of change of displacement per unit time. Look carefully. This is distance, this is displacement. What is the difference? Distance is scalar, displacement is what? Vector. I told you that whenever we deal with a scalar quantity itself, we are going to get what? Scalar quantity. But similar cases here, whenever we deal with a vector quantity, or if you divide vector quantity by time, you are going to get itself a what? Vector quantity. Okay, this is the main difference about speed and velocity, right? But one similar case is there. The unit for both speed and velocity is same. For speed, the SI unit is meter per second, or you can write meter second inverse. That means if you write, this is the same quantity. Okay, or one more SI unit is there, kilometer per hour. The same thing is here, meter per second, or meter second inverse, kilometer per hour, or kilometer hour inverse. Understood? Again, this is the SI unit. One more unit is there, the actually CGS unit is there, centimeter per second. Always remember, if there is one question that only kilometer is given and it is on the other side the time in second, that kilometer have to be converted to meter. Okay, and only if there is given hour and meter, you have to make it simple, that if there is hour given, we have to convert that kilometer to hour, or sorry, meter to hour, or hour to second. Then the things will same. That means we can simply say, if there is meter, there the time should be second. If there is kilometer, the time should be in hour. Okay, this is actually a set of unit. Okay, this is a pair. Meter and second is a pair, kilometer and hour is a pair. Okay, so this is the thing. Again, one more similar thing is there, both speed and velocity, that we told you that whenever a car moves at a speed from, sorry, not a speed, whenever car changes its position from one city to the other, the speed is not going to be the same throughout the journey. That's why we need the average speed. Once we give the speed a direction, it is going to be velocity, right? That means what? But the speed is going to be same, but the direction may be changes, right? Again, we need average velocity. Why? If a car is moving from one city to the other in the east direction, right? That means what? We are actually going to measure or actually maintain the velocity. Okay, that maintaining velocity is not going to be same throughout the journey. That means what? That velocity is going to change per unit time. Okay, in that case, similar to that speed, okay, we're going to get some average speed. Okay, the average velocity have actually two formulas. Okay, if that velocity is changing or changing of velocity is uniform throughout the journey, we can write the definition as initial velocity plus final velocity divided by 2. Okay, that means what? If I say one example as that, one car is moving from one position to the other, okay, with a speed of, okay, and start its journey with a speed of 20 km per hour and end its journey at 40 km per hour. Okay, what is its average velocity? You just have to put the initial velocity, then you have to put the final velocity, then just add it and then divided by 2. Then you are going to get average velocity. Again, if there is one question that if it is only given the displacement or net displacement and total time taken to cover that displacement, if I ask you one question that what is the average speed, then you are average velocity, then you are going to one more formula, that average velocity will be net displacement. That means net means total displacement. Okay, total displacement or net displacement by total time taken, right? Net displacement by total time. This is the main to actually formula that we should actually remember, that initial velocity plus final velocity divided by 2 and net displacement by total time. Understood? Now, what have you understand from the velocity part? That velocity mainly deals with what? Velocity mainly deals with direction and magnitude. Okay, and magnitude. Okay, if I change one of the two quantities, the velocity is going to change. Okay, if you consider that if you change the direction, velocity will be also change. If you consider that you are going to change the magnitude, velocity obviously going to change, right? Consider one thing, that a bowler give a ball to the batsman. Okay, that ball will have some kind of speed, okay, or velocity. That means 140 km/h in the south direction. Okay, then what will happen? The batsman will hit a shot. Okay, it will change its direction. Okay, and along with that changing of direction, it also changes velocity. That means what? Changing with direction, the velocity changes, na? I think yeah, you have understood the actually example, because maybe all of these students are interested in cricket. They will actually understand. Okay, the simple example is that. So by this, we have actually understood what is actually velocity is. Now we have actually understood what is actually speed is, right? Our next topic is going to be rate of change of velocity. Okay, this is our next topic. See, first we have understood what is actually rate. Okay, whenever something changes with time, that is actually known as rate. Okay, we have understood velocity. Velocity actually have both magnitude and what? Direction. Okay, and change is what? Changing of position. Okay, change is what? Change is the nature of everything. Okay, everything changes. When we are just kid, we are now man. Okay, that means what? We also have a change, right? Okay, this is a different part. This actually belongs to the biology part. Since we are dealing with physics, we have to actually think what can be there if the velocity changes with respect to time. See, just consider one uniform motion. Okay, uniform motion means what? There is going to be there is going to be same speed, there can be same velocity too. That means what? If a car is in a uniform motion, that car will have a constant speed throughout whole the journey. Okay, so if that velocity is constant, then what will be the change of velocity? Obviously zero, na? If this is a object, it changes its position from this position to this position with a velocity of how much? 10 meters per second. Okay, again from this position to this position, it again changes its position with a velocity of 10 meters per second. That means what? It is in uniform motion. Now if it is v1 and it is v2, then what is the change of motion? v1 minus v2 equal to what? 10 minus 10 equal to what? 0. That means we can say that in a uniform motion, the change of velocity is obviously 0. That means that rate of change of velocity is 0 in uniform motion. Now, what is the case in case of a non-uniform motion? In non-uniform motion, the velocities are not same. Okay, it is quietly constantly changing from one position to the other, right? So in that case, we are going to have some new term. Okay, see what is going to happen if this is one car actually. If its initial velocity is v, sorry, not initial velocity is v, its initial velocity is u. Okay, and this is the position A. When it moves from A position to B position, at B position its velocity is v. That means what? It is also v, it is also v. That means this quantity is going to be a vector quantity, because if we are dealing with a vector quantity, the new quantity is going to be a vector quantity. Simple concept, right? Now, what is its change of velocity? Okay, the change of velocity will be v minus u, right? If we actually discuss it, okay, if we actually find its rate, okay, what is the main heading? Rate of change of velocity. This is the change of velocity, na? Change of velocity. Okay, this is the change of velocity. If we need to find a rate, what we have to do? We have to divide it by what? Time. And this new quantity is known as what? Acceleration. acceleration. And this term we actually use our in day-to-day life. We say na, hey, accelerate the car, hey, accelerate the bike. We all know that. Okay, acceleration means what? Increase in speed. Increase in spin or velocity means what? There is a change of velocity, right, from one position to the other. This is the main thing. Actually, I think you have actually understood. This is the acceleration. Again, acceleration is going to be what? Vector quantity. Acceleration is going to be a vector quantity. Okay. Again, if it is a vector quantity, okay, in case of displacement, when we are discussing about the displacement, I told you that since displacement is a vector quantity and depending on that direction, that vector quantity can be both positive and negative. Okay, and basically 0 2. If the change of velocity is constant, that consider that I told you that if the velocity is same 10 meter minus 10 meter, if the total time was, okay, 2 seconds, okay, 10 minus 10 means what? 0 divided by 2 meter per second, answer will be 0. That means what? This acceleration can be 0 2. Okay, velocity can be 0 2. If you are at the standing position, your velocity was 0, right? So that's how velocity can be 0 2, acceleration can be 0 2. Okay, this is the main thing. So now we have to check, or I was telling you that acceleration can be negative and acceleration can be positive. Okay, if the acceleration is in the direction of the motion of the car, okay, consider this case. This car is moving from this in this direction. If acceleration in this direction, then that acceleration is going to be positive. Okay, and if the acceleration is in the reverse direction or in the opposite direction of the motion of the car, that acceleration is going to be what? Negative. Okay, this is the main concept about acceleration. Okay, now we have what we have got, that acceleration can be both positive and negative. Okay, now what is the unit of acceleration? Okay, we got the acceleration unit of speed as meter per second, right? And we have also got that unit of velocity is what? Meter per second. See, look closely this concept. These two, velocity, initial velocity and final velocity, both are velocity. Okay, that means we can write the unit of the upper part or the numerator is meter per second. And what in case of the denominator? It is time. That means what? It is going to be in second, right? If I bring down this second, what is going to be? In upward it will be s, in the downside it is going to be s into s. That means what you can write meter per second square, or you can write meter per second square. Similar thing. That means what we have understood that acceleration's unit is meter per second square. Okay, this is the whole concept about acceleration. Okay, you understood. Today we have actually covered speed, that means what? Rate of change of motion, rate of change of distance, that is the speed. Then we have discussed what is going to happen when we are going to give some direction to the speed. Then we are getting some new quantity or new term, that is the velocity. And velocity's definition was what? The rate of change of displacement per unit time is the velocity. Now we have changed, if we change the velocity with time or depending on time, what is going to happen? There is a new term that is known as acceleration. Now what is the definition of acceleration? Acceleration means the rate of change of velocity per unit time is known as acceleration. Clear? Simple concept. Okay, take it simply, it will be simple. Don't take stress in your brain, make it free and enjoy your life. Okay, this is the main concept about acceleration, velocity and speed. Okay, see, this is the main thing today we have actually covered. Okay, so first you should go through the video properly. Okay, if you get any doubt, okay, I'm saying any doubt, just ask me question in my comment section. I will obviously reply. Okay, though it may take some time, but I will reply, definitely reply. Okay, if there is some replies that actually can't give in YouTube, I will make a proper video on those your doubts. Okay, clear now? So we will again meet you in the next part of the video. from where we will actually some graphical representation of both speed, direction, velocity and acceleration. Okay, so we'll discuss those things in the later part of the video. So till then, what? Stay safe. Okay, stay healthy. Don't go outside of your home if it is not needed. Stay spending time with your family. Okay, it will actually increase your bonding with your family. So till then, sayonara.